Hello and welcome back again. So in this example, we're going to be using linearization to approximate the cube root of 7.998. And that is the same thing, by the way, as using differentials. And so near the end of the video, we'll make that comparison and kind of show you how they're really the same thing, but just different vocabulary. So in any of these problems, the very first thing you need to do is you need to identify the functional process that's being applied to the number you're trying to approximate. So in this case, our function that we're studying is the cube root of x. The next thing to do is find what I refer to as the nice number, and that's going to be c is equal to 8. And that's basically the closest number where you can easily take that function value without having to worry about any kind of calculator or approximations. So again, our function is cube root of x, and our nice number is 8. So our linearization formula, thinking back, is LC of x is equal to f of c plus f prime of c times x minus c. So in this case, it's actually L8 of x, and that's equal to f of 8 plus f prime of 8 times x minus 8. And so while we're at it, we might as well go ahead and find our derivative. So our f prime of x is going to be 1/3 x to the negative 2/3, which is really 1 over 3 times the cube root of x squared. So for us, we're going to have L8 of x is going to be the cube root of 8, which we know is 2, plus the derivative at 8. So that's going to be the cube root of 8, which is 2, squared, which is 4, times 3, which is 12. So that's 1/12 of x minus. All right, and so now what we want to do is actually calculate L for that number, 7.998. We don't want to lose sight of what we're trying to do. So we're going to be finding the linearization at the point 7.998. So that's going to be equal to 2 plus 1/12 of 7.998 minus 8. Be careful there. And that's going to be equal to approximately 2 minus 0.00017, which will be approximately 1.99983. And if we compare that to a value generated by a calculator, we get the cube root of 7.998 is approximately 1.99983 as well. And of course, the digits at this point will vary a little bit, but you'll notice that our linearization does a really good job of estimating the value of that function at that point. One other comment I wanted to make here is comparing this to differentials. If you think about differentials, we know that the function at x plus a small change in x is approximately the function at that point plus the derivative at that point times the dx, or the delta x, if you will. So in this problem here, if we think of x as c, we have f of c plus our delta x number is approximately f of c plus f prime of c times our delta x. So this is going to be f of 8 plus a negative 0.002 is approximately f of 8 plus f prime of 8 times our negative 0.002. So you notice that really our differential is the same thing as our linearization, and the only difference is We have x minus c in our normal formula. And here, the x minus c is actually already computed as our delta x or dx. And again, that's that small amount of change in our x coordinate.